In the last two videos, I have introduced the principle of mathematical induction and I have solved 4 problems from the exercise. Now, in this video, let us solve few more problems from the exercise. So, this is the 5th problem, that is 1 into 3, 2 into 3 square, 3 into 3 cube. As usual, as I have mentioned in the earlier videos, no need to panic looking at the formulas. So just follow the procedure. The first step is that let P of n be the given statement. Okay, the P of n be the given statement, and now check it for n is equal to 1, whether it is true for n equals to 1 or not. So n equals to 1 is nothing but the first statement we have to take. First term we have to take sum of the first one term. N means sum of the first n terms. 1 means sum of the first one term. So first one term is 1 into 3, and just replace n by 1 on the right hand side. 2 into 1 minus 1 into 3 into 1 plus 1 plus 3 by 4. Right? So now which implies 3 is equal to 2 minus 1 is 1. 3 into 1 plus 1, that is 9 plus 3 by 4. So which is equal to 3 is equal to 3. So P of 1 is true. Now let us look at the step 2. What is the step 2? So P of k, assume P of k be true. Assume P of k is true. Right? So what is P of k here? P of k is so 1 into 3 plus 2 into 3 square plus 3 into 3 cube plus and so on plus k into 3 to the power n. Wherever you have n, just replace with k. Okay, k into 3 to the power k. So 2k minus 1 into 3k plus 1 plus 3 by 4. That is what we have as a step 2. So assume P of k is true, and what to do? We need to prove P of k plus 1 is also true. We need to prove P of k plus 1 is true. Let's take what is P of k plus 1 here. P of k plus 1 is 1 into 3 plus 2 into 3 square plus 3 into 3 cube and so on. You will go up to k plus 1 terms. K plus 1 into k 3 to the power k plus 1 is equal to 2 into k plus 1 minus 1 into 3 to the power k plus 1 plus 1 plus 3 whole divided by 4. This is what we have. Wherever you have n, just replace with k plus 1. And we know that the first k terms, sum of the first k terms is true, right? We have assumed that. So we can use that concept here by taking that. So what is the sum of the first k terms? 2k minus 1 into 3k plus 1 plus 3 by 4. So let's take that. So 2k minus 1 into 3 to the power k plus 1 plus 3 upon 4 plus the k plus 1 term is, we have to add that k plus 1 term, that is 3 into k plus 1 into 3 to the power k plus 1, which is equal to, this is 2 into k plus 1 minus 1, so that 2k plus 2 minus 1, I will take it as 2k plus 1. So 3 to the power k plus 1 plus 1, k plus 2 plus 3 upon 4. So simply we have to prove that the left hand side is equals to right hand side here. Let us take the left hand side. What is the left hand side? Left hand side I have, so 2k minus 1 into 3 to the power k plus 1 plus 3. Take 4 as LCM. 4 into k plus 1 into 3k plus 1 whole divided by 4. Now let us try to simplify this. So what can be taken common here? We have 3k plus 1 can be taken common. Right? Let us try to take 3k plus 1k common here. So when we take 3k plus 1 common, okay, so by first two terms, let us take these two terms and let us take 3k plus 1 common. Okay, shall I write one more step? Okay, let me write one more step. So let's take all the like terms to side by side, that is 4 into k plus 1 into 3k plus 1 plus 3 by 4. So we have the denominator is 4, in the right hand side also denominator is 4 and plus 3 is there, plus 3 is there. Only we have to prove that this value is equal to 2k plus 1 into 3k plus 2. Now let us take 3k plus 1 common here. On taking 3 to the power k plus 1 common, our left hand side will be equal to 3k plus 1 common. What else is there? 2k minus 1, 2k minus 1, 2k minus 1 plus 4 into k plus 1 plus 4 into k plus 1 plus 3 whole divided by 4. So let's simplify this and we'll check what we have. 3k plus 1 into 2k minus 1, 4k plus 4 plus 3 upon 4. So 2k minus 4k is minus 2k, 4 minus 1 is 3, so that it will be equal to 3k plus 1 into 3 minus 2k. So this will be, sorry, this is 4k, right? So that 3 plus 2k plus 4k, right? 4k plus 2k is 6k, so 3 plus 6k will be this one and plus 3 whole divided by 4, right? And then further I can write as 3k plus 1 and let us take 3 common here. So we'll have 2k plus 1, right, plus 3 whole divided by 4. So 3k plus 1 into 3 power 1 we have here. So when bases are same, we can add the powers. So we'll get 3 to the power k plus 1 plus 1 into 2k plus 1 plus 3 whole divided by 4. What is this value? So we have this 3 into k plus 3 to the power k plus 2, 3 into 3 to the power k plus 2 into 2k plus 1 plus 3 upon 4. So which is equal to right hand side and hence proved. That is what we have right on the right hand side. So what we have, 2k plus 1 into 3k plus 2 plus 3. So 3 to the power k plus 2, 2k plus 1 plus 3 divided by 4. That is right hand side. So that hence proved. And if it is pk plus 1 is true now, when p of k is true, so from the principle of mathematical induction, p of 1 is also true. Now let's take the next problem. So as usual, the first step is let p of 1 be the given equation. P of 1 be the given formula or given statement. Now for n is equal to 1, so our p of 1 is, so what is the first term in this sequence? So in the given left hand side, so 1 into 2 is the first term, right? Sum of the first terms is equal to, replace 1 into 1 plus 1, 1 plus 2 divided by 3. Replace m by 1. So that we'll get here, so that which is equal to 2. This is 2 into 3 by 3, which is equal to 2 is equal to 2. So hence p of 1 is true, right? P of 1 is true. Now we can go with the step 2. Okay, what is step 2? So we assume that p of k is true. Assume p of k is true. And what is p of k? Assume P of k is true. And what is P of k? P of k is, let me take it as 1 into 2 plus 2 into 3 plus 3 into 4 plus k into k plus 1, which is equal to, wherever you have n, just replace by k plus 2 by 3. Right? This is the k, P of k is true. Right? So by assuming P of k is true, so we will prove that P of k plus 1 also true. Right? What to do? We need to prove P of k plus 1 be true. P of k plus 1 be 1 is true. Okay? You can write as 1 is true. Right? So what do you have here? P of k plus 1, how do you write? So P of k plus 1 is 1 into 2 plus 2 into 3 plus 3 into 4 k plus 1 into k plus 1 plus 1, and which is equal to k plus 1 into, so wherever you have n, just replace with, in the n here, right? Wherever you have n, just replace with k plus 1 plus 2. Just replace n by k plus 1, will get this. Now what to do? We have to prove that this left hand side is equal to right hand side. But we know that the first k terms in the series, we have already assumed that P of k is true. What is that P of k? That sum of the terms is k into k plus 1 into k plus 2 upon 3 plus k plus 1 into k plus 2. Right? And what is the right hand side now? K plus 1 into k plus 2 into k plus 3 by 3. So we have to prove now the left hand side is equal to right hand side. Right? Now let us take the LCM. By taking left hand side, let us take the LCM here. You will get k into k plus 1, k plus 2 plus 3 into k plus 1 into k plus 2. I think by looking at this one itself, we can say that it is equal to right hand side, right? So that is, we can take k plus 1 and k plus 2 common here, isn't it? We have two common terms, k plus 1 and k plus 2. This is common, k plus 2, k plus 2. We can take it common. So we will be having k plus 3 by 3. That is what we have right on the right hand side, hence proved. So we have proved that P of k plus 1 is true when P of k is true. So from the principle of mathematical induction, right, what we can write here is P of k plus 1 is true when P of k is true. When P of k is true. So from principle of mathematical induction, P of n is true. Okay, you can write here just like hence from principle of mathematical induction, P of n is true. Right? Now let's see the next question, 7th one. So we do the same procedure. So first we take step 1. What is step 1? So we take it as P of n. This is P of n. And then for n is equal to 1, we check whether the statement is true or not. What is the first term here? 1 into 3, which is equal to 1 into 4 into 1 square plus 6 into 1 minus 1 by 3. So this is 9 by 3, right? 3 is equal to 4 plus 6 is 10, 10 minus 9. 1 is 9 by 3, which implies 3 equals to 3. So that P of 1 is true. Now let's take the step 2. What is step 2? So assume that P of k is true. Assume P of k is true. And what is P of k? P of k is equal to 1 into 3 plus 3 into 5 plus 5 into 7 plus and so on 2k minus 1 into 2k plus 1, which is equal to k into 4k square plus 6k minus 1 upon 3. So we have assumed that this is true. So by assuming this is true, what we have to prove is, we have to prove that we have p of k plus 1 as true. Now let us take p of k plus 1. What is p of k plus 1? So that is 1 into 3 plus 3 into 5 plus 5 into 7 until 2 into k plus 1 minus 1. Just replace n by k plus 1 into 2k plus 1 plus 1. Again replace n by k plus 1, which is equal to, so what do you have on the right hand side? Wherever you have n, just replace by k plus 1. So k plus 1 into 4 into k plus 1 whole square plus 6 into k plus 1 minus 1 upon 3. Right? And we have assumed that the first k terms, sum of the first k terms is true. So by taking that formula into consideration, I can write it as k into 4k square plus 6k minus 1 by 3, which is equal to, plus so we have 2 into k plus 1 minus 1, 2k plus 2 minus 1. So I will write as 2k plus 2 minus 1 is 1. 2k plus 2 plus 1, that is 2k plus 3. Right? So on simplifying this one, I have got it. Now let us simplify this right hand side. K plus 1 into 4 into k plus 1 whole square. Oh my god. Right? 4 into k plus 1 whole square plus 6 into k plus 1 minus 1. So can I keep it as it is? Let us keep it 4 into k plus 1 whole square plus 6 into maybe 6k plus 6 minus 1. Okay, so that is nothing but 5. I'm just taking here. Maybe, okay, maybe while you are solving, maybe you may think that it is much better than this one. So you can prove up to here, left hand side, if we get this one first, right? Let us see that. To prove it, let us take left hand side. Right, left hand side is k into 4k square minus k into 4k square minus plus 6k minus 1 plus 3 into 2k plus 1 into 2k plus 3 upon 3 by taking LCM here. So anyway, the denominators are same by now. So only thing is that we have to simplify numerator and we have to show that this numerator is equal to this numerator. Right? So let us try to do that. So let's simplify this, the numerator. Okay, so 2k plus 1 into 2k plus 3 is 4k square plus 6k and then 2k, then 8k and then 3, right? Let me simplify in that way. So we have left hand side is equal to 4k square plus, so let us multiply this. Maybe I will multiply this entire thing. Okay, so 4k cube plus 4k cube plus 6k square minus k. So first I have multiplied this k by all the terms inside the brackets plus 3 into, what do you have, plus 3 into 2k plus 1, 2k plus 3, that will be 4k square plus 6k, right, plus 2k plus 3. So what we have upon 3. So now let us simplify it again. So 4k cube plus 6k square minus k plus 3 into 4 12k square plus 3 into 6, so 6 plus 2 I can take, so that this is 8k, so 3 plus 8 3 into 8 is 24k plus 9 upon 3, right? So now we have to simplify it. 4k cube plus 6k plus 12 square, this is plus 18k square, minus k plus 24k, this is 23k plus 9 by 3. That is what we have. Okay, instead of factorizing this, I prefer to take the right hand side and simplifying that. So let us take the right hand side and simplify. So what do you have on the right hand side? K plus 1 into 4 into k plus 1 whole square, and let us simplify it. So k plus 1 into 4 into k plus 1 whole square is k square plus 2k plus 1 plus 6k plus 5, 6k plus 5 upon 3. So now we can take this as k plus 1 into, right, 4k square plus 8k plus 1, right? I will take it as 4k square plus 8k. Okay, let me write one more step, no problem. Plus 6k plus 5 whole divided by 3, right? So now we can see that this 8k plus 6k is 14k, right? And 4 plus 5 is 9. So let us see that this right hand side is equal to, so k plus 1 into 4k square plus 14k, 4k square plus 14k plus 9 whole divided by 3. Now multiply this, you will see that k into 4k square is 4k cube plus k into 14k is 14k square plus k into 9 is 9k. Now 1 into 4k square is 4k square, 1 into 14k is 14k plus 1 into 9 is 9. I have taken the multiplication directly. How do you multiply it? To algebraic expressions. First we take this k and it has to be multiplied by all the terms. 4k square by into k plus 14k into k plus 9 into k. That is I have written here. And then we have to take 1 and then 4k square into 1 plus 14k into 1 plus 9 into 1. Right? So that is what you get. Now let us see. I'm simplifying it. 4k cube plus 18k square plus 23k plus 9 by 3. Let us see now this simplified expression is equal to the left hand side or not. Yes, of course. So right hand side is also equal to left hand side, hence proved. So now we have proved that p of k plus 1 is true when we have proved that p of k plus 1 is true when p of k is true, right? So now from the principle of mathematical induction, we can say that p of 1 is true. Now let's take the 8th question. At least it looks like simple, right? They are just lengthy problems. All are simple problems, but just lengthy ones, right? And you have to write, okay, while you are showing your work in the exam, you have to write each and every step clearly, and you have to write the words also, sentences also. Okay, what you have done and why you have done, how to mention. That is important in this principle of mathematical induction. Step 1 is p of k is the statement, and then let p of n. Let p of n be the statement and be the given formula or the given equation, right? And for n is equal to 1, p of 1, let us test here. We will come to know that 1 into 2 is equal to 1 minus 1 into 2 to the power 1 plus 1 plus 2, which implies 2 is equal to 2. Because 1 minus 1 is 0, so this whole term becomes 0 and we are left with 2 on the right hand side. Hence it is proved. P of n is true. P of 1 is true. So that we will take the step 2. Assume p of k to P of k is true. Assume P of k is true. So now let us take P of k equals to 1 into 2 plus 2 into 2 square plus 3 into 2 cube. Wherever you have n, just replace with k. K into 2 to the power k and k minus 1, 2 to the power k plus 1 plus 2. Right? This is P of k and we have assumed this is true. Now what to prove? We need to prove P of k plus 1 is also true. So for that, let us take 1 into 2 plus 2 into 2 square plus 3 into 2 cube plus up to wherever you have n, just replace k plus 1 into 2 to the power k plus 1 and then k plus 1 minus 1 into 2 to the power k plus 1 plus 1 plus 2. Okay, this is the sum of the k plus 1 term for any values, any positive integer value of k. Okay, so now let us simplify it. For simplifying it, first what you have to take is, first you have to take the first k terms of this series. Obviously it has one term more than the P of k, right? Because k plus 1 terms you have taken. So first k terms plus we will be left with the last one term, right? So sum of the first k terms, already we have assumed that is true. So I can take now the sum of the k terms as k minus 1 into 2 to the power k plus 1 plus 2, right? So k minus 1 into 2 to the power k plus 1 plus 2 plus k plus 1 into 2 to the power k plus 1 last term plus k plus 1 into 2 to the power k plus 1, right? And is equal to k plus 1 minus 1, that is k plus 1 minus 1 is k into 2 to the power k plus 1 is k plus 2 plus 2. We have to prove that this left hand side is equal to right hand side. So in order to prove this, what I will do is, I will take left hand side. So what is left hand side here? K minus 1 into 2 to the power k plus 1, right? And let us take this plus k plus 1 into 2 to the power k plus 1 plus 2 k into 2 to the power k plus 2 plus 2. Sorry, we have to prove it. We have taken left hand side, right? So that we don't need to write this. Now let us simplify this. On simplifying this, we will get that. Let us take 2 to the power k plus 1 common here, right? 2 to the power k plus 1 common here. So that into k minus 1 plus k plus 1 plus 2, right? This is further I can write it as 2 to the power k plus 1 into 2k plus 2, right? So you can see here 2 to the power k plus 1. So k plus k is 2k and minus 1 plus 1 is 0. So here we can see 2 to the power k plus 1 into 2. So we have 2 to the power 1 here. When the bases are same, we can add the powers. So 2 to the power k plus 1 into k plus 2. So it is nothing but 2 to the power k plus 2 into k plus 2. This is what we have on the right hand side, k into 2 to the power k plus 2, right? We can write, right, k into 2 to the power k plus 2 or k into 2 to the power k plus 2 into k, which is equal to right hand side. Hence prove. So P of k plus 1 is true. So from the principle of mathematical induction, so P of 1 is also true. I hope you have understood. We'll solve few more problems in the upcoming videos, and thank you for watching.